It's good to be here.
Yeah.
We are in Intertool Messe 2024, and today we brought some samples.
Yes. Yes. Can you tell us a little bit about the samples we have seen here?
Yeah, so there are some different samples. Some are for laser welding, some are with laser cleaning.
Mm-hmm.
So with laser welding, we have aluminum plates welded together, and we are welded with different powers.
Mm-hmm.
It's possible to see the underside as well, that it's welded through.
Mm-hmm.
Not fully, it's possible to increase power a little bit, but this is what it looks like. And also the same samples are cleaned with laser. So you can see in the center line, it was cleaned with high power, and there is some surface roughness with not so much reflection going on.
Mm-hmm.
And this part in each sample was cleaned with lower power setting. So it's possible to see against the light that it's cleaner in here where it was cleaned rather than all displays out there.
Yeah.
So it's possible to increase surface roughness or to save as it is originally.
Okay. And for which kind of material does it work?
So for welding, it works for most of the metals. So it's possible to weld aluminum together with carbon fiber.
Mm-hmm.
Now it's the end of the exhibition, so we lost all our aluminum and carbon fiber samples, but we still have some steel with carbon steel. And the spectrum of materials is reasonably broad. Also, it's possible to weld, for example, it's not common to weld aluminum with carbon steel, and it's possible to do it. But also it's possible to weld really thin sheets of metal. For example, stainless steel of 0.5 millimeter to stainless steel of 5 millimeters without problem. And it's a little bit tricky with other technologies.
Okay.
So that's main benefits and materials for laser welding. But speaking for laser cleaning, material spectrum is even broader. It's possible to clean. We have here paper, cardboard sample, and black paint was removed from it. It's a spray paint. So it's possible to remove paint or various coatings from even materials which are really easy to damage. So cardboard is okay, it's pretty hard, but it can be something even thinner as aluminum foil, or maybe paint. On the churches, for example, we have sometimes requests to clean paint graffitis, and even if paint is sticking off the surface already, it's possible to remove it without damaging it. So,
and what about other materials like carbon fibers or something like that? Is it possible to use laser for that? Or
of course, it's possible to use fiberglass to clean, for example, paint from fiberglass surfaces. So all yachts, all gliders, and maybe other airplanes encounter this. Also, it's possible to clean and restore even leather.
Leather.
Yeah. So it's like shoes or maybe some ancient things that you may encounter. Also,
that's interesting. Yes.
Yeah. Wood, for example, it's really common. We get a lot of requests from wood restorators because they have to repaint the sculptures, and it's possible to remove paint without damaging big material. And so it's one of the best technologies for that. Of course, it's often used in metals to remove oxide layers or to remove grease from engines, from the parts that cannot be damaged by mechanically. Because I always like to mention that laser cleaning is great and ideal in cases where you must preserve undamaged surface. For example, for metal cleaning, it would be mostly engine parts or maybe some other really fine details. But if you can, for example, clean metal mechanically with some brush and the damage done to the surface is no problem, laser cleaning might not be the fastest option.
What does it mean? What does it mean it's not the fastest option? How fast can I clean the surface? Can you tell us something about the square meters, or that we can clean by in a certain time, or from which factor is it related? Yes.
Yeah. So cleaning time is roughly, as you see here in example, hopefully in the video, you can see that red line running.
Mm-hmm.
It can go a little bit faster, 10% faster than it's currently running.
Mm-hmm.
And cleaning of square meter speed really depends on material thickness, deposit, and type. For example, cleaning rust will be reasonably fast. You can clean square meter in less than 15 minutes.
Okay.
But for example, for paint removal and thick paint removal, it may take for square meter from metal surface.
Yeah.
It can take, let's say, 20 minutes to 40 minutes, depending on paint type, color, and geometry of the object. Of course, in some really complicated cases, if the object is not flat, but let's say a lot of holes that you have to clean inside, or really complex geometry, it can take even an hour for square meter, or maybe a few hours.
Okay.
So it really depends
of the surface and of the geometry of the topology of the surface. Okay. Okay.
And it also depends, I would say, on material final look, or what you intend to see, because for aluminum, it's possible, of course, it will be much faster to use really strong power pulses. And it will be there will be surface roughness, and it will be not that shiny. But maybe you have to preserve the shininess of the metal. You will have to use lower power, and it will slowly remove paint compared to the higher power parameters. And that time for the same material, same cleaning, can take twice as much. So it truly depends.
Okay. And what's about the energy power? What kind of systems are you doing, or are you producing?
Yeah. So the powers, pulse powers, in terms for our system's maximum pulse power is 8 millijoules.
Okay. So
for most materials, it's enough to remove it, and without any issue. It can be as hard as epoxy resin, and 8 millijoules will be perfect for that.
Okay.
However, for majority of materials such as paint removal or oxide removal, 0.1 millijoule is sufficient, and it's also possible to achieve with our systems.
Okay. And what is the big difference between a laser cleaning system and a laser welding system?
The main difference is that laser welding is ideally working in continuous wave mode. So it means it's emitting light non-stop, and during it, you get a lot of heat concentrated on a really small space.
Okay.
So there's instant heating and melting, and that's great for welding, great for cutting, unless you want to work with really thin metal sheets.
Okay.
So in that case, our welding system laser can produce modulated pulses. So to work in certain duty cycle that is set by parameters, and thinner metals can be welded together. And speaking about laser cleaning systems, so those systems need the opposite of laser welding. They need really short pulses, so there would be no heat transfer to the material that is being cleaned. So our laser cleaning systems work in pulse durations from 10 nanoseconds up to 500 nanoseconds. It can be adjusted. It also depends on repetition rate and power setting. And let's say on average, just 100 nanosecond range. And during such short pulses, the base material does not absorb the heat. So, for example, if it's cardboard, it will not burn. Or if it's wood, it will also not be damaged.
Okay.
So this is the maybe main difference from 3-in-1 systems, where one system can do everything or as advertised, but they cannot, for example, paint sensitive materials.
Okay.
And with our systems cleaning, it's much more sensitive and much more precise for final application.
But the source itself for the cleaning and for the welding, is it the same, or is it what?
It's different.
It's different.
It's different. It's for laser welding, it's continuous wave, or it can be modulated pulses.
Okay.
And for laser cleaning, we use MOPA source. So it's a different type, even though it's both fiber lasers, but it's different type.
Okay. Okay. So what else can you tell us about, do we need some, is it, if we compare the laser welding system with Wolfram inner gas system, what is the main difference? So what is the advantage? Why I should buy a laser welding system instead Wolfram inner gas system? What is the main difference? So what is the main advantage of it?
So the main benefits of laser welding system is, maybe one of the first is, if you're using it in handheld mode, it's much more easier to achieve good quality welds compared to, and without experience, person will achieve within first hour high quality welds. For example, this sample, I welded myself without much welding experience prior, and to achieve such welding, it might be hard with technologies, or without training special. So it's really intuitive how to use it. Also, it's a much faster process, and it's really perfect for long straight lines, or where samples are not, let's say, curved, but diameters are 20 centimeters for a pipe. So it's hard to access. If we're talking about really small pipes, for example, 2 centimeters diameter, and we have to join it in T-shape, this Pringles chip like the welding seam, it might be a little bit hard to do in a handheld mode. You might want then to consider robotic arm or maybe our technology.
So that means it is possible with the same system to do an access with the robotic arm.
Yes.
So it's possible to use it with the robotic arm.
Yes.
And is there any interface foreseen, or is it something that you have to add it? Is it already there, or is it an option?
It is as an option. So it's possible to have just for hand cleaning and for option for laser welding. So there's additional interface to connect to the robotic arm, and it can be programmed to start, laser stop, and all the other features that are necessary to change.
And is it also possible, for example, to choose a certain program over the use it as a slave, for example, and the robot is choosing the right program for the...
Yes, in principle, it's as possible.
Okay. And what's about the laser cleaning? Is it also possible to do a solution, a robotized solution?
Yes, I would say it's even recommended, because working in handheld mode, sometimes it's hard to maintain the certain distance from the cleaning surface, and the final result can be not as good, especially working with materials where you want to preserve the gloss. And with robotic arm, it's much more precise movements, and easier to work, faster to work, however, requires extra investment. So it really depends on the case, but it can be automatized and also controlled from robotic arm system.
Can you tell us what is the funniest applications you ever had with laser cleaning? Have you something in mind that you can tell us about?
One of the funny applications was to clean frescoes in a church. They were overpainted just with some paint 50 years ago, and it had to be removed. And we had to clean faces of some figures on those frescoes, and it felt like cleaning person or just washing him, and it was a little funny. Or cleaning a sculpture in general is also a bit interesting experience. Of course, from those our samples, there were some wooden figures, and there were some leather figures as well. So cleaning leather seems really counterintuitive. For laser, it seems it should burn, but it does not. So.
Oh, nice. Is there a difference regarding the safety classes between the FEMTA laser cleaning system and the FEMTA
welding
system? Is there difference, or is it the same laser class?
Yeah, so both systems are laser class 4.
Okay.
It's possible to work with them in open space. What I want to say by that is not that you can work in open space, but that you can easily access various objects and you control cleaning or welding by your hand. And it does not have to be automatized solution. You can work by hand. So it's laser class 4. It's quite powerful lasers. And it's possible to reduce that laser class safety to laser class 1 if you work in enclosed structure together with automatized solution, robot. Regarding safety, you should, of course, always wear safety glasses when working in the same room where the laser is working. And together with all the people who are in that room, of course. So it's recommended to have separate room or separate place to work with laser. Another safety feature is, of course, all the fumes coming from the cleaning. We often have a fume extraction unit, so where all the fumes get sucked out and filtered and then released back into the room air or maybe outside.
And is it a standard system, or does it need several filters, or is it always necessary, for example, to have a carbon filter in it in the extraction unit, or is it? What will you recommend?
Yeah, it really depends what you are cleaning, and sometimes in some specific cases, for example, working with wood and just renewing the wood surface. Sometimes even just the regular vacuum cleaner can do the job. But of course, if you work with paints or some materials that might be toxic when evaporated or when exposed to high temperatures, we recommend using HEPA filters together with carbon filters. So in most cases, it's of course better precaution to have proper filtration. But in really specific fields, it has to be considered that maybe it's not as dangerous as those fumes. So,
and as I understood, the welding source is much more powerful than the laser cleaning source. And is there any security when I use the gun here, the welding gun? Is there any security that I cannot use it as a laser gun?
Yes. Even though it's called laser gun, it has security features. So there is a ground loop or just a loop. So you have to attach ground to the detail that you're working with. And once the laser gun has contact with the part, only then it can be engaged. And if there is electrical current going back through the loop. If laser gun is lifted off the ground or of the loop, it stops automatically. So it's a safety precaution.
And do I have here several nozzles, or is it necessary? And why if yes, why you have several nozzles?
Yes, there are several nozzles for an application. So I have them right here. We are in different forms. We will put them in front of camera, so it's possible to see the difference. And they're used for different type of surfaces. So, for example, this one is used for corners. It has angled tip, and it's much easier to follow the corners. However, if you want to weld flat surfaces, this ending will be much easier to weld because it has flat surface and a good gas extraction. Tip. This nozzle is used for corners also, but from the outer side. So it fits really well between two pieces. And it's possible to weld like this. Much easier than with any other of those nozzles. And this one, again, is for the flat surface. And it's also important to say that it's possible to weld with additional welding wire, but also without additional welding wire. And the results sometimes can be better with or without. It really depends on how well the pieces are cut and how well they fit. In most cases, using welding wire, of course, will make material thicker in the welding space if you need strength. But for example, for aesthetic welding or aluminum, sometimes it's nice not to add additional wire in it because final product is smoother. And the welding seams, for example, in those samples are without any additional welding wire.
How delicate is the surface cleanness for laser cleaning? Is it recommended from your side to do pre-cleaning before welding, or
yes,
does it works without, or can we clean it? How? What would you recommend?
Yes, so of course, in every field, probably cleaning to having clean metal parts for welding, it's an advantage because no additional debris will get mixed into melted metal, and the welding seam will be stronger. However, in principle, it's possible to weld samples without cleaning them. We have exact example here. This aluminum was not cleaned at all. And this aluminum was cleaned before welding, and this one without. Cleaning after the welding can be also done.
By
It can be done even with laser welding system itself.
Great.
It's not as ideal or not as precise as using laser cleaning system, but it can be done. And you can see examples of low power cleaning after welding the materials right here on the right side of each sample. And before sample, it was cleaned along the welding beam.
Do we need any gases for welding or for cleaning?
Yes, for laser welding, it's necessary to use any inert gases to prevent oxidation of welded part.
So it's similar like wick or motor.
Yes, in some kind, because the main idea behind those inert gases is to prevent any oxygen from the air reaching the welding seam or molten metal, so it wouldn't oxidate. And for laser cleaning, there are no requirements for inert gases. Of course, in really certain applications, it's possible to use inert gases, for example, to prevent oxidation. But usually, the power settings is reasonably low to prevent any heat transmittance into material, so it doesn't make new oxide layer. It usually just removes oxide layer itself.
And final question regarding the Intertool. What would you say? Is it, from your point of view, was it a successful exhibition, or what is your impression about the Australian exhibition Intertool?
It's of course, it's a great experience. It's a great experience to see new country, to see new people, how exhibitions work there. And I think there was a lot of interest to see technologies, to see the samples, to touch them. Many people they saw only videos, but could not touch the real sample. And I think it gave them some new prospects and ideas where they could apply it. So I think that's the most important thing you can give is knowledge and ideas. So I think it was quite successful. How do you think it was?
From my point of view as well, it was. I had another exhibition 1 week before, and you cannot really compare it, but from my point of view, it was really a nice success because we got a lot of demands and also a lot of shown interest from the visitors. So I'm really impressed. From my point of view, it was really a nice success.
I see. Glad to hear that. And
me too. Thank you very much for this talk. And I hope I see you soon. I see you soon again. Yes. Thank you.
Thank you.
Thank you.
Thank you.